Alright, we're going to talk about the volume of prisms and cylinders today. But before we do that, quickly I want to just show a visual of, we talked about with surface area that solids have, some solids have something called a net, N-E-T. So if we look at this triangular prism here, it's one of my favorite candy bars, Toblerone. It's a triangular prism, triangular, congruent triangles for the bases, and then the sides are rectangles. So if we were to open that up, this would be the net of that triangular prism. So we can see we still have the two triangular bases, and then the sides are rectangles, and when we look at them, they make a rectangle, a larger rectangle. And so that's why we had the, for the lateral area, the perimeter of the base times the height. Remember, the height is the distance between the bases. So obviously with this packaging there was a little bit more, and I cut that part off because they would need more for it to overlap so they could glue it together. And there was another flap up here that I cut off, that because in a regular net we just have the actual faces. Okay, so I was trying to give you a little visual for that. Now, volume is the number of cubic units contained in the inside of a solid. The volume of a prism is the base area times the height. So I'm using the same kind of color coding that I used in the previous notes. Purple for the bases, green kind of for the lateral area, the height there. Now we can look at a cube as slightly different because the base, the base is a square, so the base area would be side squared times the side, because a cube, they're all equal, so that would be s cubed. But we don't need to memorize that as a separate formula. Anytime we see a cube, we can still find the area of the base and multiply by the height. Cylinder, sometimes some books will give this formula, and that maybe can be confusing for some people, but it's still the base area times the height. The cylinder, the base is a circle, so it's the base area times the height. So it's really just that one formula, so we don't want to get confused on that. Cavalieri's principle says that two solids with the same height and the same cross-sectional area at every level have the same volume. So you may have some weird looking shape and you may have a rectangular prism, but if each level that we check has the same area, then they're going to have the same volume at the end. Okay? So let's look at a question here. The box shown is 2 units long, 6 units wide, and 3 units high. How many cubes would fit in the box? What is the volume of the box? Okay? So if we try to set up things the same way we did the other problems, so we have the height, and the height is going to be 3 units. Okay, and then we have the base, and the base is 2 units times 6 units. So that's going to be 12 units squared. And if we put those together, we can find the volume. So if we multiply those together, we're going to get 36 units cubed for the volume. Now, it said how many cubes, unit cubes. A unit cube is a cube that's 1 by 1 by 1. So the answer to that question is 36 cubes would fit in there. Okay. Unit cube refers to 1 by 1 by 1. 1 by 1 by 1. That looks a little awkward. Okay, so let's move on. Now, what we're going to do on these next two is we're going to put it all together. So we're going to do the surface area and the volume. Okay, so usually on a test in class we would have these questions like this where we'd ask you all of these things. So here there's a little warning there. Where are the bases? Remember, the bases have to be congruent polygons, or in a cylinder, congruent circles. So remember, the height is the distance between the bases. So that's going to be 3 millimeters. Okay, this right here. Okay, height is the distance between the bases. So that's 3. Now the perimeter of the base. Now as you look at this, you could use the Pythagorean theorem on that, but maybe you would think about, we've talked about Pythagorean triples a few times. So it's always good to start with those. And so right now would be a great time to write down the 2 main Pythagorean triples that we have brought up several times. If you can't write them down, that means that you need to do a little bit more. You need to study, you need to memorize these, put them on a flashcard, do something. 3, 4, 5 is one. And the other that we use a lot is 5, 12, 13. Now there are others, but those are the ones we want you to memorize. So now, if we compare this, you might say, well, that's half of that, and that's half of this. Maybe we could take half of that, and then that would tell us that this would be 6.5. So that would be 9 and 6 would be 15. Okay. Now remember, to get the lateral area, we multiply those two together. So that's going to be 45 millimeters squared. Okay. Now the base area, triangle, 1/2 the base times the height. Now here we're talking about the height of the triangle, not the height of the prism. So we want to kind of realize this is a different height than this height. Now I would take half of 6, and that would be 3. And then you'd have 3 times 2.5, or you could think of it as 3 times 250. $2.50 times 3, that's going to be $7.50. That's millimeters squared also. Now, going for our surface area here, that's going to be 45 plus 2 times 7.5. So 2 times 7.5 is 15, so that's going to be 60 millimeters squared. Okay? Now, when we move over here to find the volume, remember the volume is the base area times the height. So it's going to be these two things. So the base area is 7.5 and the height is 3. So you can do this, a lot of times it's easier if you stack them like that and just multiply, but here, hope you can do this. 3 times 7 is 21, and 3 times 50 cents, $1.50, so that's 22.5. Or, if you need to, go ahead and stack it, 22.5, 1 decimal, so 1 decimal, and don't forget that's going to be units cubed. So that's going to be our volume. So now would be a good time to pause and cover this up, and this follows the same pattern. So if we cover this and we give it a shot, so the height is going to be distance between the bases, so that's going to be 13 feet, and the circumference is 2 pi r. You got to be careful. Did they give you the radius or the diameter? They gave us the radius, so that's right. So that's going to be 8 pi feet. Okay. Now, the lateral area, we just multiply those two things together. So 8 times 13, that's 80 plus 24. It's 104 pi feet squared. Okay. Now the base area, base is a circle, and that's going to be pi r squared. So that's going to be 16 pi feet squared. And so now we have 104 pi plus 2 times 16 pi. So that's going to be 32 pi. If we add this together, that's 136 pi feet squared. Okay, now if we move over here to find the volume, we have the base area, which is 16 pi, times the height, which is 13. So I'm going to write that over here. That's going to be 18, 3 and 1 is 4, 0, 0.61, so that's 208 feet cubed. Alright, so moving right along to the next page. Use the measurements given to solve for x. So if we look at this, our height is actually x. We can put centimeters on there if we wanted to. So our base area down here, so there we go. So our base is right there, and our height was right here, following the same kind of color pattern that I've been trying to use. So the base area is going to be 11x centimeters squared. Now the volume, they actually gave us the volume. The volume is 396. So remember, how do we get that? We take the base area times the height. So if we multiply those together, we would get 11x squared. So if we divide by 11, 396 divided by 11, that's going to be 3, just kidding, 6, so that's going to be 6. So that worked out pretty nicely. So now we have 36 equals x squared. So we're going to square root both sides, and we would get the absolute value of x equals 6. So we would get x equals plus or minus 6. But the only answer that makes sense there is 6 centimeters. It doesn't make sense to have dimensions of -6 in this situation. So we will just focus on the positive 6. Alright, so now we have a similar question. So this time, okay, so it's a little bit different. So we have the height is 5 feet. Now, the base area, if the cylinder is going to be, so the base is going to be a circle, so it's going to be pi times r squared. Well, if the diameter is x, that means that the radius is half of x. Now, okay, so we could do that, and then the volume, we were told, was 277, and the volume is this times this. So I'm going to do a little bit of work here. So it's the base area times the height. So if we square this, that's going to be 1/4, so that's going to be pi over 4 x squared, and then times the height, base area times the height. Okay, so that's what we have right now. So the first thing we could do probably is multiply both sides by 4. So 277 times 4 here, and this side times 4, we'll cancel that out. So that's going to be 28, and 28 and 2 is 30, so carry the 3. So that's going to be 1008. And then what do we have left here is 5 pi x squared. So now we're going to divide both of these by 5 pi. So that's a little bit awkward. That leaves us with x squared equals that. And then, so this is going to cancel. And then if we take the square root of both sides, we'll get that x equals the square root of 1108 over 5 pi feet. And if you're curious as to what that is, it is approximately 8.399 feet. Okay? So, concrete is used to fill around 2 bricks. Okay, so there's a brick here. A lot of bricks are red, so I don't have a red highlighter, but I have a pink. So the white is the concrete, and the pink is the brick that the concrete is around. Okay, find the volume and the weight of the concrete used if the concrete weighs 0.084 pounds per cubic inch. Okay, so let's do the total first. So the total, we're going to want the height, which is 3 inches. And then we're going to want the area of the base, which is 13.5 times 4. So 13.5 times 4, carry the 2, that's 12, 13, 14, okay, that's 5. And there was 1 decimal, so 1 decimal, so that's going to be 54 inches squared. And then the volume is going to be that times that, so 150 plus 12 is 162 inches cubed. Okay, so now if we do that again for the brick only, let's do 1 brick actually, so let's focus on one of these bricks. So the height of the brick is the same as that, so that's going to be 3 inches. Now the area of a brick, the base of the brick, is 3 times 8, so that's 18 inches squared. So the brick itself, 3 times 18, is 54, actually. Okay, so that's 1 brick, but we got to multiply that by 2, because there are 2 bricks. So that's going to be 108 inches cubed. Okay, so if we take those and subtract, we would have 162 minus 108. So that's going to be, we borrow 1 off of here, that's going to be 4, and we borrow off that, that's going to be 5, so that's going to be 54 cubic inches. So that's the volume of the concrete around there. Now if we take the weight times, it's 0.084 pounds per cubic inch, and we have 54 cubic inches, so we can multiply that. So that's going to be 16, carry the 1, that's 33, 0, that's 20, carry the 2, 42, carry the 4. So that's going to be 4, there's 3 decimals, so 4.536 pounds. That's how much that concrete would weigh. Okay? So, 2 solids have the same blank and the same blank. 2 solids have the same blank and the same cross-sectional area at every level, then the 2 sides have the same what? So, 2 have the same height, then they have the same volume. So it's a good idea in multiple choice questions to try to come up with the answer yourself and then see if your answer is there. So I have height and volume, and that looks like the first one. But another good thing to do in multiple choice is just to check the other answers, and maybe one of those will make sense. You'll say, oh, wait a second, that should be the answer. Okay. Find the volume of the solid formed by revolving the rectangle around the y-axis. So here's the y-axis. So if we take this rectangle, we revolve it around, that would come maybe a little bit further than that. Okay, it would look something like this. So try to imagine taking that rectangle and spinning it around the y-axis. We get this, and I have an example of that as well. So this isn't a rectangle, but we have this shape, and if we take it and we revolve it around this axis, then we get a solid like this. This is supposed to be a little ice cream cone decoration, but paper, three-dimensional, right? So if we take something and we spin it around, we create a volume. Alright. So in this case, if we take a rectangle and we spin it around, we get a cylinder. Okay? And so if we take the height of that cylinder, that would be 3 units. And if we take the area of the base, that's going to be a circle, and the radius is going to be 5, the x-coordinate there. So it's going to be pi 5 squared, so that's going to be 25 pi. And then the volume, remember, is the base area times the height. So that's going to be 75, and we'll say units cubed. So probably should come back here, put units squared on that, and units on that. Okay? So that's something we do in calculus, actually. I actually have that ice cream cone to show my calculus students the same thing that we just did right there. Except in calculus we can actually find the volume of this. Strange. This part is basically just a cone, so we could find the volume of that cone, but finding the volume of this part over here, the ice cream part of this, would be more difficult. Okay, so now if we take this, and now we're going to go around the x-axis. So if we do that, we also still get a cylinder. Okay, so if we take that rectangle, maybe I can shade that a little bit. That's the rectangle we started with. And, so the same rectangle, but now we went the other direction. So let's see what that does. So now the height, remember it's the distance between the bases, and the bases are those circles. So now that's 5. And now the base area, the radius of the base is now 3. So pi r squared, 3 squares 9. So that's going to be 9 pi. And so you can see we actually get a different volume. That's going to be 45 pi units cubed. Okay, so you just did something very similar to what we do in calculus. So you did some calculus today. Alright. Now we have a little bit of review here. So let's try to do this somewhat quickly. Actually, we haven't done parabolas yet, I don't think. So actually, this is not review. So maybe I'll only do part of that. So this is a little bit tricky. So it's definitely divisible by 5, though. So 245. Now 5 is not a perfect square, but it'll give us a smaller number, and hopefully we can figure something out. So that's 20. And 5 into 45 goes 9 times, and it worked out really well because that's actually a perfect square. So square root of 49 is 7. And we're going to find the area of a triangle, 1/2 the base times the height. Remember, the base and the height are perpendicular to each other, and the height can actually be outside the triangle. So 1/2 of 5 millimeters times 7 millimeters. So since they're both odd, it's actually probably easier to multiply those together first, and then take half of that. So that's going to be 35 over 2, or 17.5. And there we go. Okay. Now, I'm going to do one of these now, because I'm pretty sure we haven't done graphing parabolas yet. That's coming up in a couple weeks. But I'm going to do one of them. Okay. So I'm going to skip that one. I'm going to do number 3 here. So graphing parabolas is a pretty big deal. You're going to have to do that. You should have done in Algebra 1. You're going to do it again in Algebra 2. So what I like to do is I like to compare this to point slope form. So what I want to do is add y. So compare to point slope form. So if I add 8 to both sides, I'll get y plus 8 equals 2x minus 2 squared. Okay, so that's like point slope form. So what do we do in point slope form? We find the point, right? So what's the point here? The point that we have is 2, -8. Well, that's a very important point, actually. It's the vertex. Okay, so the vertex is 2, -8. So we come over here and plot that. 2, -8 is down here. And we could put it on the chart if we wanted to, also. We'll actually put it down here. You say, well, how would you know? Well, we have lots of choices. But let's go back to this. Opens. So just like a line that has a positive slope goes up, a parabola that has a positive, we call this the A value, if that's positive, it goes up, which should be easy to remember. Positive slope of a line means the line goes up. Right? So positive A value of a parabola. This when we have something square, a quadratic equation is the graph of it is a parabola. Okay. Y-intercept. Well, just like on a line, the y-intercept is when x equals 0. So if you plug in 0 for that, what's going to happen? We're going to have 2 times 0 minus 2 squared minus 8. So minus 2, 0 minus 2 is -2. -2 squared is 4. 4 times 2 is 8. 8 minus 8 is 0. So actually, the intercept there is 0. So maybe we can put that one in there, and then maybe we can go 1, -1, 3. Now the reason I put this down here, some people always put the vertex in the middle, but we have symmetry. So I decided to put it down here, and I decided to put these in there because these numbers are smaller and they should be easier to plug in. Now, don't let this freak you out. We're going to teach you this in a couple weeks. So if you don't remember this at all, we will be going over this again later. Might as well give you an introduction to it now. Alright, so here, the vertex, the x-coordinate of the vertex on the parabolas that we're going to do in geometry, which are all x squared. We're not going to do any y squareds, I'm pretty sure. So the axis of symmetry is x equals whatever the x-coordinate of the vertex is. So what you can do is draw a dotted line through there. And that's the line of symmetry or the axis of symmetry. It's dotted because it's not really part of the graph, but it does help us because we can reflect any points we have over that line. Okay, so now if we plug in 1 here, 1 minus 2 is -1. -1 squared is +1. +1 times 2 is 2. 2 minus 8 is -6. So that is right here. Now we just said we can reflect that over the line there. Now I'm going to plug another point in. -1. -1 minus 2 is -3. -3 squared is 9. 9 times 2 is 18. 18 minus 8 is 10. Okay. Now over here, by the way, we reflected that point over, and 3 was the same as 1, so that's -6. Now we just got -1, 10, should be right there, and that is 3 away from the axis of symmetry, so we can put a point on the other side 3 away also. We're almost done here, so this is going to look something like that. Okay? Yeah, that's a little bit bumpy on this side over here, but oh well. Okay, so that's just an introduction to something we're going to do in a couple weeks, graphing parabolas, 3 different formulas. So it's about that time. Have a good day. Don't worry about this too much. We'll do it again later.